Okay, so today we're going to talk about different types of polygons. So to begin, we have polygons again being closed figures. Um, we have two different ways that we can look at them. The first one is going to be concave. So like the examples you see behind me. Concave, the way I like to think about it is it's with a cave, like it caves in at some point, meaning that at some point there is a vertices that is within two other vertices. So it looks like it's caved in, pretty much. So like this one looks like it's a caved in quadrilateral, but it's a pentagon. And this looks like it's a caved in triangle, but it's a quadrilateral. How do I know that? Because of the number of sides it has, right? Convex is every angle is pointed out. It's convex. So that would be like what you're more commonly used to. A lot of times people call these regular polygons, and that's an issue because the word regular for when it comes to polygons, it comes to shapes, means that all sides and angles are equal. So all angles are equal inside, and all the sides are equal or congruent. So that's what it means for it to be regular. Do not call these regular unless you know that all the sides are the same and all the angles are the same. So we have concave and we have convex. That's the first differentiation or classification among polygons. Okay, so we can say it's either concave or convex. If it's concave, they'll be caved in at some point. I mean, you could even draw it to be like that. This is still caved in at a point. If everything's popped out, it's convex. Okay, all right. So that's the first classification. The second one is probably the one that you're honestly most used to. And that is, how do I name a polygon based off of its different sides? Right? So again, we'll start off with the first one that you know. So how do we name polygons based off its different sides? Well, first of all, the word poly means many. So it's a mini-gon, and meaning it has many sides. Okay. Well, and in the geometry that you're going to be using, known as Euclidean geometry, for those of you that want to look that up, we have the smallest polygon is a triangle, 3 sides. And that's because it has to be a closed figure. So if you just had 2 sides, it wouldn't be able to close. It would just be on top of itself, so it would be a line. So it doesn't become an actual closed figure on the plane. So here we have a triangle, that it will be the smallest that we can use in this geometrical space. So triangle. Why is it called a triangle? Because tri means 3 and has 3 angles. Because it has 3 angles, it also has 3 sides. So this is a triangle. Okay. Well, after that, when we add another side to it, we call that a quadrilateral. And as stated before, lateral means side. So quadrilateral, 4 sides. Okay. So there are lots of properties with quadrilaterals. There are lots of properties with triangles, and triangles are the basis for all of the others. If you take triangles and put them together, you can create the other polygons. And so if you understand trigonometry, at least the basics, then you can actually use the information you know here and relate it to every other polygon. But we will look at quadrilaterals specifically and look at their special properties because these two are honestly the ones that are most commonly used, along with circles, which we'll talk about in the future. But these two are the ones we most commonly see in day-to-day life, and especially when it comes to building things. And there's a reason for that because they kind of make things a lot simpler because we've also been able to study a lot of special properties with each one. As again, to the other powers, usually the next one that comes up is a hexagon, which is just because of it having 6 sides. So it's just 2 of these. So it's again becomes a lot easier to look at. But out of that aside, triangle and quadrilateral are the 2 ones that we'll be looking at mostly. But we are going to talk about the others. So a pentagon will be next because it has 5 sides. So I'll draw a pentagon. Okay, and then hexagon will be next here. Okay, and then we'll do a heptagon or septagon, meaning 7, whichever way that you want to kind of say that. I want to make this one look nicer. Let's do that. Okay. And then we'll do an octagon here. Okay. And then we can keep going if we want to. So we have a triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, meaning 9, decagon, deca 10, so 10-gon, and then dodecagon is 12, and they have all special names for all of them. Now, in general, though, because these are polygons, meaning many sides, we could have a 108-sided figure if we wanted to. But in general, what we do is we just call them n-gons, where n is the number of sides. So if you want to call a triangle a 3-gon, most people will probably look at you like you're crazy, but that's fine. I mean, you know what you're saying. It has 3 sides. So this, if I want to call it a 4-gon, I can. If I want to call this a 5-gon, I can. If I want to do 6-gon, 7-gon, 8-gon, and so on and so forth. I can do that all I want. And honestly, that makes it a lot easier, especially when you get to higher number ones and you don't have to like try to Google to find out what the name is. And most of the time you can't, especially for the kind of weird, obscure ones. But you can always just put the number of sides, dash gong, or just call it a 12-sided gong, or however you want to say that. But these are different types of polygons that we have. We also look at it based on the number of sides. So first, is it concave or convex? Second thing is, how many sides does it have? And that will define which of these shapes it is, which polygon it is. Because a lot of times people may see a concave quadrilateral and they think, oh, that's a triangle, but it's not because it has 4 sides. So, all right. The last thing, though, is that our shapes can be regular or irregular. Now, earlier I told you, do not call convex regular polygons because people do that a lot. Regular means that all the sides and all the angles have to be the same measurement. They have to all be congruent in order for it to be regular. That word regular means like, because it's normal, because it's just easier to deal with. It's the norm. It's what we want to see when we have a triangle or a quadrilateral or a pentagon. We want all the sides to be the same measurement. We want all the angles to be the same measurement because it makes our calculations and everything else so much easier, so much smoother, and honestly, really beautiful. Now, triangles, honestly, at some point, it might have been kind of worshipped in Babylon's equilateral triangles. So when it was a regular triangle, so all the sides and angles were equal, so that's 60 degrees. That's why their whole number system was based off 60, just because of their obsession with the equilateral triangle. So that's kind of cool to even think about, that the fact that if it's regular has been so important for so many millennia. So anyway, well, let's just kind of classify that real quick. So if it's regular, then all sides are equal or congruent, and all angles are congruent or equal. Okay. Again, this is very important. Regular, all sides are equal, and all angles are equal. And when we were looking at triangles before, we had 2 other words that we talked about: equilateral and equiangular. So if all the angles are equal, it's also called equiangular. Okay. If all the sides are equal, this is called equilateral. All right. So if it's regular, it's equilateral and equiangular. But just because it's one of these does not mean it automatically is the other. The only exception is triangles. As we saw before, triangles that are equilateral automatically have to be equiangular because of the relationship between sides and angles in triangles. That's not the case for any other side. For example, and this will probably be one that will make some of you angry, but I'm going to draw I'm going to draw something that is an equilateral quadrilateral, and I'm going to draw something that's an equiangular quadrilateral, and I'm going to draw something else that's a regular quadrilateral. Okay. So this is an equilateral quadrilateral, and this is called a rhombus, in case you want to look it up. This is equilateral because all the sides are equal. Okay. This is an equiangular quadrilateral. Equiangular because all the angles are the same. This is called a rectangle. Okay. And then last but not least, this is a regular quadrilateral. Regular meaning it's equilateral, all sides are the same measurement, and equiangular, all the angles are the same measurement. This is called a square. So this is equilateral, rhombus, equiangular, rectangle, and regular is a square. These are all not the same. They are different. This has all equal sides. This is all equal angles. This has both all equal sides and all equal angles. All right. And we'll study that more when we're looking at quadrilaterals, because that's a very important difference to understand. Because a lot of times when people see one of these, they automatically say it's a square, and that is not true at all. It's not. Something else, a lot of times when people see this, they'll say, "Oh, it's just a rectangle," or they'll make up something else. I don't know. But we want to stay away from that. Equilateral, equiangular, and regular. Those are different terms when it comes to any shape besides a triangle. Okay? So those are our different classifications for triangles. So we have concave and convex, meaning that concave, it's caved in. So like this kind of shape, if these are straight line segments. Convex, everything's pointed out. We have our classification based off the number of sides. So triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon, and so on and so forth. Or just call it n-gon, whatever the number of sides is, and n-gon. So 108 gon, 1024 gon, whatever you want to call it. And then we have classification based off of congruent measurements within it. So we have regular, if it's both equiangular and equilateral, meaning that all the sides and angles are congruent. Equilateral, meaning that all the sides are congruent. Equiangular, meaning all the angles are congruent. So those are our three ways to classify it: concave, convex, based on the number of sides, and based on the congruency of sides and angles. So either it's equilateral, equiangular, or it's regular because it's both. All right. So we're going to dive a lot more into this now. We're going to be looking at more shapes and different things that we can do with them based off of these properties actually here. So let's get right into it. I'll see you soon.